Hello again, this is Grace at UC Berkeley in the Berkeley Biomechanics Laboratory. In this video, I wanted to talk a little bit about how the research that I present in different articles is supported and funded, and where you can find some of these articles if you wanted to look them up yourself. Research is conducted in many different locations, from the private sector in R&D departments to national laboratories, as well as at academic institutions and universities. So there's a wide range of potential institutions for basic science research all the way up to applied research. Often research that is conducted in the private sector, for example, places like Google, Apple, and Medtronic, may be published, that research may be published in white papers, but often these are results that are held and kept as trade secrets because it helps the company have an advantage over their competitors. So they don't necessarily want to publish their findings in the open. In the United States, we have 17 national laboratories. Where I am in the San Francisco Bay Area, we have 3 national laboratories, including one in Berkeley here, right in the Berkeley Hills. These national laboratories often have a specific focus area, whether it's materials or energy, trying to advance the big challenges and problems in those spaces. Then we have R1 research academic institutions. R1 just meaning that it brings in a lot of research funding, typically from the federal government, from federal grants to support basic science research and even translational research, more applied research. So much of my research over the past 20 years has largely focused on basic science research. But in the last 5 to 6 years, my research has transitioned as I collaborate more with colleagues at UCSF to thinking about more translational type of research, which is closer to being able to be directly applied to patients and consumers. As you go from the private sector, research that's conducted in the private sector, to research that may be done in a national lab, and even in this national labs that include places like NASA, up to the academic research institutions, there's a difference in the likelihood of the research findings being published. At academic institutions, there's an incentive for professors and researchers to publish their work and to make that available to the public as well as to other researchers. And that is tied to their promotion as they move up in their career. So as a taxpayer, you've helped to support the research, but how do you actually find out what the results were? Let's say you wanted to read the research paper yourself rather than just waiting for it to be presented in the news, for example. In the 1990s, the NIH, the National Library of Medicine, actually created a website called PubMed, where scientific research articles that have been peer-reviewed are published and available to be searched through this database. And so it links to the different journals. Prior to 1996, researchers would actually have subscriptions to individual journals and then receive the hard copy on a monthly or bi-monthly basis, whatever it was, the frequency of publications. So having the NIH put a digital database really helped to increase the availability and visibility of research articles in different journals that you may or may not necessarily have an eye for previously. Starting in 2004, though, Google Scholar also was launched through Google, and that includes not only peer-reviewed articles, but you can even find conference proceedings. So conference proceedings are typically short-form publications that are presented at meetings prior to going through the full peer review process. More recently, in 2013, there's been a push to publish articles prior to the peer-reviewed process. And part of this is to get research out there earlier, especially in research fields where the pace of the research is quite fast, particularly in CS. And so researchers wanting to make sure that they get their stuff out there prior to somebody else, or being scooped, as it's called. So we have meta archives and we have bioarchives. And just announced last week, there's Open Archive, which is a joint venture between the Chan Zuckerberg Initiative and Cold Spring Harbor Laboratory to be able to provide the server space and to ensure that bioarchive and mid-archive will be able to stay operational. Because as things move digitally and people upload their research articles, this is going to require more and more server space. Now, even though the NIH PubMed database allowed people to see what has been published and to read the abstracts, which is a short summary of the article, most people could not actually access these research articles unless you had access to an academic institution library, for example. For me, UC Berkeley Library. But in 2013, there was a memo by then President Obama stating that any research that has been funded by federal funds needs to be open access, so available to anybody that wants to read it. And the idea behind this was the taxpayers have paid for this research, so therefore the taxpayers should be able to see this research and the results of what they had funded. And so there has been a shift over the last 10 years, both at academic institutions and federal agencies that are stating and making sure that anything that they have supported is published, unless, again, it has security concerns where it cannot be published. While there are many different journals, and there's a growing number of journals every year for each subdiscipline, many of these journals are actually published by a small number of publishing houses. One of the bigger ones is Elsevier. There's also Wiley and IOP Publishing. So these publishing companies control a lot in terms of the fees that are charged to libraries for subscription fees. Back in 2019, Berkeley's library, UC Berkeley's library, actually canceled their subscription with Elsevier. And this was a big push because at the time, Berkeley wanted to be able to have all of the research published from Berkeley researchers published as open access articles. So this is also kind of in line with that 2013 presidential memo of making research that is supported by federal funds or taxpayer dollars to be open to the public and accessible to the public. And in 2021, Berkeley did have a 4-year contract and agreement with Elsevier to be able to do open access. So when I publish a paper, and if it's Wiley or even Elsevier, I see a separate thing and note about publishing my particular papers as open access. So now I get it from two different ends of whether it's from UC Berkeley or from the federal funding agencies about making sure that my research is actually published in open access journals, or even if it's not an open access journal, in a journal that provides open access options. While it's great that people have more access today to scientific literature than ever before, I think understanding scientific literacy is becoming increasingly important. As I mentioned, researchers are incentivized to publish. Graduate students are incentivized to publish to be able to graduate, to get their PhD. Professors are incentivized to publish because it's connected to their potential for future research grants as well as for their future promotions. And when we're looking at what gets published, more exciting research tends to get published easier. This also means when you find no differences or the null hypothesis is not rejected, this can mean it's quite challenging for your research article to get published. Stuart Ritchie talks a bit about this in his book called Science Fictions, where he talks about some of the concerns about publications and sample biasing in terms, or publish biasing. One of the challenges, particularly with biomedical type of research, is being able to get sufficient sample sizes. We often can't do population-based studies, but it doesn't mean that the small samples and the smaller studies can't give us some important information. However, we do need to be mindful about the types of differences that we may see. So, for example, let's take a study question, a research question that we think that there are more men with blue eyes than women with blue eyes. So we take a random population of equal numbers of men and women, and we look to see how many of them have blue eyes or brown or non-blue eyes, so any other color other than blue. And let's say that the first study sees this large difference in men versus women having blue eyes. So they come with the conclusion that men have more, it's more likely that men will have blue eyes than women. And so that will hit the newsstands, so to speak, the scientific newsstands, or even the general public, and that will be anchored in people's mind as being fact. And now any other paper that comes after that, if it doesn't agree with that, they're going to have to really demonstrate with greater data and support to refute the initial paper. So it may be that they saw this great difference in that small segment of the population because the sample size was a bit small. And as you get more samples and you do more of a population type of analysis, you might end up seeing that there is no difference in men versus women in terms of the propensity for having blue eyes. Or you may see, even with the similar type of sample size, that you get the opposite result, where women have a more likelihood of having blue eyes than men. And I've seen this in my own research, where I tried to replicate research where there was a statistical difference reported. And when I looked at the analysis for the data at Berkeley, I saw no statistical difference. And then even when I went back to the original data and tried to reverse engineer what they did with their statistics, I found that even with their data, that there was no difference. But publishing a null result is very challenging in science. It's not typically something that publishers want, because there are many different reasons why you may have a null result that you need to look further into. Or it could just be that there are no differences. And so that's just one of the many challenges in terms of trying to be able to do good science. So science is definitely a process, and we move incrementally. So it can take quite a while before we have a good understanding of any particular problem space. As I mentioned, journals want to publish high impact papers. High impact papers being papers that they think will be cited many times in the future, because that helps to drive their business. Now, this then creates incentives for the publishers, as well as, again, for the researchers. One of the things that I also keep an eye out is to look at who is funding the research. Not only do we have research supported by the federal government, but sometimes you have industry-supported research or foundation-supported research. And that alone is not necessarily a bad thing. It's nice to have different avenues for research studies to be supported. However, we've seen in places, for example, in the nutrition field, how this can really drive research outcomes and results that are reported. And the more famous example of this is the research around fat and sugar, and how fat for decades was pushed as being problematic for people's diets, and sugar was ignored. And we now know that sugar plays a really important role in terms of obesity and metabolic diseases. And then the other thing that you want to look at, and this takes some experience and knowledge in the field, is looking at the study design. A very good study design will focus on the objective, the scientific objective, and the statistical analysis will match with the scientific objective. Often you'll find that there may be some control groups that are missing, or the statistical analysis that is done doesn't necessarily match the scientific question that was presented in the motivation in the introduction of the paper. So I bring this up because, particularly with the example that I gave earlier about my experience with the statistical analysis, is the statistical analysis that you choose to run can really change the outcome and the conclusions that you draw. So we want to be really mindful about that. And the knowledge around statistics has changed quite a lot in my 20 years in research. And people are a lot more knowledgeable about the statistical models that are run and the ways to analyze the data. And I think more importantly, more and more researchers are providing the data, their raw data, either on GitHub or through the journals. And this really allows for an opportunity for other researchers to look at the same data. Because sometimes we get too close to the research and then we forget to kind of take a step back and to reevaluate it differently. And this allows the same data sets to be used multiple times, increasing the value of the collected data, because often the most expensive part and time-consuming part is collecting the data. So let's say you've downloaded your first research article and now you're interested in diving into it. Typically where I would start is that abstract. Usually there's a 350 word to 500 word abstract that should give you a full summary of the paper, of what was done, what they found, and what their main take-home point or conclusion was. Ideally, it would give you some quantitative metrics. Often, though, I do see a lot of abstracts that don't really give you a concrete take-home message. Some of the best ones are very clearly written and actually quite succinct. The next section is going to be the introduction of the paper, and this will set up the motivation for the research. It will tell you what is the big picture problem that they are trying to solve and give you some background about whether it's a disease or the joint, some background information about what are the gaps in the literature as well as what is known in the literature, what is recent research found that has led the researchers to their scientific question. I tell my students to end their introduction on what is the objective and what is the hypothesis for the study design. Then the next section is the methods section. This tells you how they did what they did. Ideally, the methods section would have enough information so that any researcher would be able to replicate the study on their own. Often, it is very challenging to replicate studies. There was a research article that showed that about 85% of biological research findings were not able to be replicated in a different laboratory. Part of this is because you don't have enough information. We don't realize the very little details that we do that contribute to the outcomes of our study design. Sometimes there's larger information that's missing from the methods. And even other times there's just typos in equations and mistakes there that no matter how much we try to make sure that we publish a perfect paper, there are some errors there. This will also include the statistical analysis, how the data was collected and then how the data was analyzed. After the methods section, you have the results section. In the results, it should just present the data that was collected, the quantitative values. It should have no interpretation of the results and what they mean. That is all reserved for the discussion section. So the results section should also have figures, and I tell my students that your figures should really be able to tell your study as well. If you think about your paper in words, but also a pictorial visualization of the study. And it should be clearly visualized. It is also helpful to include tables, but often those tables in terms of data interpretation and data analysis can be quite challenging. It can be very helpful for people, for example, creating computational models where they need the exact numbers for the data. So there's a mix there of what is helpful in terms of conveying your data and your research versus being able to provide information to future researchers. And this is also why publishing raw data has become more and more valuable as it's become more available too. The last section is the discussion section. This is the section where the researchers will incorporate and interpret their findings with respect to data that's existing in the literature. This should be explaining why is the research important? Why are the research findings important? What made sense? What are outstanding questions based off of things that maybe even the researchers don't understand from their own data? And this can lead to future work by the researchers themselves, or perhaps by future researchers, other researchers in other laboratories. It's a way for researchers to communicate to each other about potential interesting things that they think are potentially interesting. to better understand the disease or to better understand how the body functions. And then you end on typically, you'll see quite often a paragraph that talks about the limitations of the paper. There are always limitations in any paper, so it's just a matter of whether or not it's included in the paper, and then ending on the conclusions. And this should have your take-home point and message of the study design. So with that, hopefully you feel a little bit more comfortable and confident about being able to find a research article for yourself on the internet, as well as being able to read through it. And reading through scientific research can be quite dry and take quite a lot of time, especially if you're new at it. But once you start to read in a certain field more and more, it becomes a lot more comfortable, and you start to see similarities in different introduction sections. So enjoy the process.